Okay, hello everyone and welcome to this video. In this video I will be showing you how to install YOLO on Linux. I've already made a video on how to install YOLO on Windows. I'll be giving a link to that in the description. Also I'll be sharing a link to this article as well. So head over to this article and go to section C, installing on Linux. Installing YOLO on Linux is a fairly simple process as compared to Windows. So okay, let's get started. Step 1, open a terminal and clone Darknet. Now this is the official Darknet GitHub repository. Okay, you can head over there and download this, or just simply run this in your terminal. Clone this. Okay, this will download the Darknet repository here in your home directory. Okay, let's move on to the next step. Install CUDA and cuDNN on Linux. I have made a separate article for that, so you can refer to it. If you already have CUDA and cuDNN installed on your system, you can move on to the next step. Or if you don't have CUDA and cuDNN installed, let's quickly head over to that article and set up CUDA and cuDNN. Now again, in this article as well, we have two sections, one for Windows, one for Linux. Right now we need to use Linux. Okay, step 1, download and install CUDA toolkit from this website. You can also download previous versions of the archive of previous CUDA releases. You can also find this link on this page here. I'll be downloading an older version as I already have CUDA 11.0 on my other systems. So download this CUDA toolkit 11.0 update 1. Or if you are downloading any newer version, make sure you have compatible cuDNN available for it. I'll cover that once we reach that step. Okay, over here choose the operating system, choose your architecture, choose the distribution, your version, and I'll choose installer type run file local, and then you'll see these two installation instructions. Okay, if you want to know your architecture, just simply run uname -m, and there is it. You can see this is my architecture. Now before we run these installation instructions, you have to do this in the terminal. Run these two commands first. Update and upgrade all the packages in your Ubuntu distribution. Okay, next add the PPA graphics drivers PPA repository into your system. Press enter. Again sudo apt update. Now next what we have to do is install the NVIDIA driver compatible with the CUDA version we have downloaded. For CUDA 11.0 the minimum driver version is 450.51.06. You can find out the minimum driver version required for your CUDA over here. As you can see, CUDA toolkit and minimum required compatible driver versions. I'm downloading this for this CUDA 11.0, 11.0.3. So this is the minimum required driver version. Okay, now so I'll manually install the NVIDIA driver using this command. Yes. As you can see, this is downloading 450.51.06 for me. So I'm doing this manually, so if you want to change the driver version in the future, you know how to. Obviously this is also included in the CUDA toolkit that we will be downloading later on, but I'm doing this manually, so we will uncheck that option in the CUDA toolkit later. Once the driver is installed, you have to reboot your computer. We'll reboot the system later. Right now just run the next commands. Okay, again make sure you're in the home directory. Run this, create a folder named installers in the home directory, and then change directory to installers. And now we can run this command, the command we saw on this page, the installation instructions. Use this first command. I've also given this command over here, both these commands. And this will download the CUDA installer over here in the installers folder. Okay, I'll pause this video and come back later once I have downloaded the CUDA installer. Okay, so it has downloaded the CUDA installer for me. So once this is downloaded, you can run the next command, that is over here as well. You can close this. This can take a while, so just be patient. Okay, once we're at this page, this says existing package manager installation of the driver found. It is strongly recommended that you remove this. We don't have to remove this because I've already chosen the correct version. You can simply click on continue, accept the EULA license agreement, enter. Now over here you can uncheck this, as we have already installed this manually. So okay, now finally click on install. Okay, so once it is installed, you will see a summary like this over here. We did not select driver, so that's not a problem, we have already installed it. Okay, make sure that the path includes this LD library path. So okay, just follow along. Open the bash rc script file. Go at the bottom and add these two lines over there. This is just setting the path variable like we do in Windows. That is it. To save it, press Ctrl X, Y, enter, and that's it. Now to update your current shell environment, run this source bash rc. Okay, it's done. Now we can reboot our system to see if the NVIDIA driver and CUDA installation process was successful or not using these two commands, nvccc-v and NVIDIA SMI. Let's reboot the system. To reboot, just type sudo reboot. Okay, so I have rebooted the system. Now we can check if our CUDA installation was successful or not using these two commands. So open a terminal and run nvcc-v. Okay, so this is showing my installed CUDA version, release 11.0. Now you can run the other command, NVIDIA SMI. This will give you the driver version as well. So as you can see, this is showing me the driver version that I had installed, 450.51.06, my CUDA version, and also okay, you can see over here my GPU, GeForce GTX 1070. Okay, so that's how you can check. If you made any errors during the installation process, you will see that this command won't give you any output. So make sure to follow all the steps exactly as I've mentioned in this video. You won't have a problem. Okay, now we can move on to the next step. Step 2, that is download and set up cuDNN. Head over to this link to download cuDNN. So we have a few versions available for CUDA 11.0. as you can see. I'll be downloading this cuDNN 8.0.5 for CUDA 11.0. Open this, click on this first link, cuDNN library for Linux. Now you have to be logged in order to download this cuDNN archive. Create an account on NVIDIA. Okay, once you're logged in, just click on this link and this will download the archive for you. Save this link. This will be around 1 GB. So okay, so the download is complete. Now you can just copy this to the installers folder where we downloaded this CUDA installer as well. Okay, now moving on to the next step. Just you can run this command to unzip this cuDNN archive. Open a terminal, change directory to the installers folder. We have this cuDNN archive. Enter this command. Okay, so that's done. As you can see, this has unzipped this folder over here. The cuDNN archive contains these files. Basically these are the files that we need to copy inside a location where we have installed our CUDA files. So copy the contents from this folder to the CUDA main directory. Okay, so for that all you have to do is just run these commands. Change directory to CUDA, this folder, go inside this and just copy all the files in both these folders to this location. This is the location that we are copying the files to, where we have our CUDA installed on our system. Okay, so that's done. Now copy the second command, enter. Okay, so that's done too. We've copied all the files inside these folders that we unzipped in the cuDNN archive to the corresponding folders inside the CUDA main directory. So okay, now that is how we set up CUDA and cuDNN on our Ubuntu system. Moving on to the previous article where we were installing YOLO on Linux. So now we're done with CUDA and cuDNN installation. Okay, so next we have to install OpenCV on our system. We have three methods for that. The first method is install OpenCV from Ubuntu repository. This is the easiest method. You just have to use these commands. However, this method won't install the latest OpenCV release. The latest release that you can install using this right now is OpenCV 3.2. Right now when I'm making this tutorial, but the latest official OpenCV release is at 4.5.2. Or you can install using this pip install command. This will install the latest version for you. You need to have pip install on your system. I have pip installed. Just type pip install or pip3 install OpenCV Python, whatever you have configured on your system, and this will install the latest OpenCV release for you. So you can also confirm the version of the OpenCV installed on your system. Just import the cv2.module and print the version. So okay, this is how you can install in Ubuntu Linux using the default OpenCV installer. This method will install OpenCV for you. That will be compatible with the Darknet executable file that we will be creating later on. This will have the GPU support. However, using method 2 or method 3, you can build OpenCV from source. You can customize the OpenCV that you are going to build on your system. You can add additional libraries that you want, and that is a better option. Method 3, however, is the best option. Is build OpenCV from source with CUDA support and also enabling OpenCV DNN CUDA module. This gives us the fastest inference for YOLO object detection. So I'll be making a separate article on how to install YOLOv4-Darknet for OpenCV DNN CUDA module. So if you've watched my previous video on how to install YOLOv4-Darknet on Windows, I've also mentioned over there, mentioned these two steps there as well. And also I'll be making a separate video for OpenCV DNN CUDA module for Windows. I'll try to include both those steps in one video on how to install OpenCV DNN CUDA on Windows as well as on Linux. So make sure you subscribe to my channel so you get notified when I release those videos. And okay, if you can just install OpenCV using the first or the second method on Linux, which are simpler. You can search for this method online, but if you want to start with OpenCV DNN CUDA module, you can refer to these two articles. I've given them over here in this blog, so hopefully that will help you install it. But okay, since I already have OpenCV on my system, I have installed OpenCV from source with CUDA support, enabling this OpenCV DNN CUDA module. I have OpenCV 4.4.0, so I won't be installing OpenCV. Now we can simply move on to the next step. Step 2, make changes in the makefile. Now these are the changes that you can make in the makefile over here inside the Darknet folder. This is the makefile. Open it using any editor. Okay, now these are the changes. You can also read more about these changes on this LXCAB's official GitHub repository. How to compile on Linux using make. So these are the changes you can make, but if you're just starting out as a beginner, I'll just recommend you just make these 4 changes. The rest of the changes are for later stages once you know how to use YOLOv4 and Darknet. So right now all I want to do is just change these values in the makefile: GPU, cuDNN, cuDNN half, and OpenCV, and then lastly this architecture. I'll show you how. First make changes over here, change this to 1 1 1, this to 1. Now we have to set the architecture over here. This is the architecture. This depends on your GPU. So since I have NVIDIA GeForce GTX 1070, I know my architecture is 6.1, the compute capability, so I'll use this. I think yes, they already have this in the default makefile. They don't have it for the latest GPUs, so that's okay. If you have a different architecture, you can just paste it over here like this. Let me show you where you can find out the architecture for your GPU. Go to this link and you find the compute capabilities over here, your GPU compute capability. Now I have a GeForce product, so, and it's for notebook, GeForce GTX 1070. So this is how you can find out the compute capability, that is the architecture over there. So we have these new GPUs that have a higher compute capability. That won't be mentioned in the default makefile, so you can make the change here. Okay, so that's it. Save this file. And okay, let's move on to the next step, that is run make command. Now we have saved this file, you can close this, and now again change directory to home, go inside the Darknet folder. Let's clear this and finally run make command. This will compile the Darknet executable for you. You might see a few warnings, but as long as there are no errors, it's all okay. This might take a while. Okay, so let's head over to this folder. Now you can see we have this Darknet run file over here that we will be using to run all the commands for YOLO. We have created this Darknet executable file. Now okay, let's move on to the next step. Step 4. You can download the YOLOv4 weights file. Just run this command, it's easier. You can also find this in the official LXCAB GitHub repository. You will find all the weights file over there, from YOLOv3 to YOLOv4. You can go over there and you can see, you will see this, the config file, the weights file, the pre-trained weights file for training. You can download it from there as well, but just open a terminal and type this. Okay, so the download is complete. If you head over to this folder, you can see we have the YOLOv4 weights file over here, and that's it. We have set up our YOLO Darknet environment. We've also downloaded the YOLOv4.weights file, and okay, now we're ready to use our YOLO Darknet. Now let's move on to the next section, that is YOLO usage on Linux. I'll show you a few commands on how to use YOLO on Linux. so just follow along. Okay, to run detector on Linux, use this command. You can use either of these two commands. Okay, let's run the first command. So what we're doing is basically running YOLOv4-Darknet on this image over here, doc.jpg, using the weights file over here and the config file over here, the YOLOv4.cfg file. As you will see in the command, we have the YOLOv4-cfg file and the coco.data file, YOLOv4.weights file. In this command we just have the cfg file. Yeah. Let's run the first command. So as you can see, it is showing my GPU and cuDNN half as 1. Let me show you. So since we set CUDA, GPU, cuDNN and OpenCV to 1 in the make file, you can see it has detected the OpenCV, cuDNN half, GPU and cuDNN for it. The CUDA version is 11.0 and the cuDNN that I had set up 8.0.5. So okay, I also had set up OpenCV version 4.4.0 on my system, so make sure you have OpenCV on your system. Okay, let's see the predictions. You can see it has predicted all these three objects with more than 90% plus accuracy, and has also detected this spotted plant in the back. The YOLOv4 weights file is much better than YOLOv3 weights file. So okay, let's close this, move on to the next command. This is also to run detector on an image. The command is very similar. Run this, it will do the same. Okay, so that is how you run detector on an image. That was simple. Now for multiple images you can use this command. What you have to do is manually give the path over there. Now since we're in the darknet folder, you can either put your images over here and just give the names of those images. Right now we have a few images over here, so what we'll do is give the path to this image, eagle.jpg or horses.jpg, data / horses.jpg. okay, so that is how it's done. You close this, it will ask for path for the next image. Give the path to the next image. Okay, so that's it. Can quit this. Now moving on to the next step. Okay, you can also change the detection threshold. So the threshold determines the minimum required confidence or required to detect an object. So the default is set to 0.25. so okay, if you want 50% accuracy, you can set this to 0.5. so for instance, in this first video it had detected the spot plant with around 33% accuracy. I'll change this to 50%. so you'll see it won't detect the potted plant now. Okay, so as you can see, it has now detected the potted plant. You can increase or decrease the threshold as you like. Again, let's close this. Moving on to the next step, that is real-time detection on a webcam. Okay, For webcam, you have to run this command, darknet detector demo, instead of detect test as we did for the images. We'll use the same command for video as well, but right now for camera, this is the command. So okay, as you can see, this is detecting all these objects in this frame. Okay, let's close it. This is for camera. Now this will obviously depend on the speed of your GPU, since we set GPU as 1. Okay, let's close this. Okay, so now moving on to the next part of this video, running detection on a video. So to run detection on a video, all you have to do is run this command. Again, the command is the same as the previous one for the webcam. All you have to do is add this parameter, video file, and it will run the detection on the video for you and show you the output. However, to save the video output, you have to run this second command. You can also save the output. Okay, pass the video, and again the output file name, you have to give a name over here for the output file that you want to save. Let me show you by running both these commands. Okay, I have downloaded a video for test purposes. Let's copy this to the darknet folder, just paste it over here, and okay, let's run this command. So just change this parameter to the name of the video. Now obviously this depends on your GPU. I have a very old GPU, so it's really slow. Okay, now so this is how you view the output for video object detection. Now let's close this and save this file. Okay, so now let's run the other command to save the output of the detected video. Again, give the path to the video you want to run the detector on, and finally the name of the output video, how you want to save it. Let's save it as output.avi, change directory to darknet. Okay, so it has finished detection on this video. You can look at the output. This is using the official YOLOv4 weights file. You can see it is also detecting the person in the vehicle as well. Okay, so now again this will depend on your GPU. If you have a good GPU, the detection will be really fast for you. If not, the detection will be very slow. I'd recommend you get a better GPU or try to find any instance online, like in Google Colab, so you can run this over there. But this is how we install and run YOLO on our system. So okay, these are the basics for it. So I've covered everything in this video that is in this article. Okay, that's it for this video. If you've enjoyed this video, please click on the like button. Make sure to subscribe to this channel, and okay, I'll see you in the next one.